Welcome back to Think Thrice Problem Solving. Today we're going to be solving a fun geometry problem. So let's go ahead and take a look at this one. So our problem is we have this equilateral triangle, RST, and it's bisected on the three sides by the points E, A, and Q. And if we connect the corners of our triangle to those bisection points, they meet in the middle of the triangle here. So what we would like to do is we would like to find the volume that's created by rotating the pentagon texes. So the pentagon going up over like this and rotating that around the axis RQ. So what we're going to be left with is a shape that looks something like this guy down here. Okay. If you'd like to give this a try, go ahead and pause the video and take a few minutes to try to solve this on your own. Otherwise, let's go ahead and go into my solution. Okay, so we know that one side of this triangle has a length of 12. So that's given to us above. So what does that tell us? That tells us that this length AR is 6. So what I'd like to look at here is we see this overall shape here. We notice that we have this shared angle up here at the top. And I'd like to invent a new triangle, or we'll take a second before we do that. So the first thing I want you to notice is that we have two similar triangles here. So I have a right triangle here that shares this angle at the point R with this triangle here. Okay. So we know the overall side length is 12. We know the angle at the base here is then going to be a 60-degree angle, or in radians it's going to be pi over 3. So to get the length of our side RQ, we know that side RQ is going to be 12 times cosine, or 12 times sine of pi over 3, which gives us 12 times sine of pi over 3. Sine of pi over 3 is root 3 over 2, which will give us 6 square root of 3. So that's our overall side RQ. Okay. So what I'd like to do now is I'd like to take a look at a new triangle. So let's look at the length Rx. So if we want to get that length Rx, since we have similar triangles, I know that Rx divided by Ra is going to be equal to the length of Rs over the length of Rq. And I actually know most of those lengths. So that's going to tell me that Rx over 6 is equal to Rs, which is 12, divided by 6 root 3, which tells us that the length Rx is equal to 12 divided by the square root of 3, which is equal to 4 times square root of 3. Okay, so now we have the length of Rx. So we have this length. We have our overall length. What I'd like to do now is I'd like to take a look at this shape right here. So in order to calculate this volume, I think the easiest way to do it is if we look at the overall shape of the cone, and then we subtract this top cone up here, and we also subtract the cone that's created by cutting out the bottom portion here. So if we take that overall shape and we subtract the two cones that I've just said, we'll get our shape on the left. So that's the kind of problem that I want us to look at, and that's why we're going to make this next decision. So because of that, I'm going to look at this triangle right here as well. And this triangle is going to be similar to both of our other triangles. because once again, it's a right triangle and it shares an angle. So what I'm interested in is now this length, which I'll call A, this length, which I'll call B, and this length, which I'll call lowercase r. Okay, so using the similar triangle, so seeing that I already have Rx, so I already have A plus B. So A plus B is going to be equal to 4 square root of 3. And since I have similar triangles here, so since this orange triangle and this purple triangle are similar triangles, I can now calculate a few other things. So I can now calculate A. So let's look at these two similar triangles. So I'm going to have A over 6 is equal to 6 divided by the length of Rx, which is 4 square root of 3. Okay, so that's going to give me that A is equal to 36 divided by 4 square root of 3, which is 9 over square root of 3, which I can rewrite as 3 square root of 3. So if A is square root of 3, B equals A plus B minus A, which is just going to be square root of 3. 4 square root of 3 minus square root of 3. So now I have the length A and I have the length B. All I need is that length R. So how do I get the length R? So looking at similar triangles now, let's look at the orange triangle and the purple triangle. So R over 6 is equal to 6, that's this length down here at the bottom, divided by 12. So that tells me that my radius is going to be 3. All right, so now we are almost done here. So let's look at these 3 volumes here, and let's try to figure out what the volume of these 3 guys is. Okay, so my first shape is a shape of a cone. So if we remember our volume for our shape of a cone, our volume for our cone is going to be 1/3 the area of the base times the height. So the area of our base is pi times 6 squared. And our height is going to be our length RQ, which is 6 square root of 3. We determined that above. So this is our first shape. Our second shape, which we can label blue. So our second shape is going to be 1/3 pi times our radius squared. So our radius is 3 squared. And we're going to multiply that by the height. And the height here is the length A, which is 3 square root of 3. And then if we look at our last shape we're going to be purple. We're going to have 1/3 our pi times 3 squared again. And our height is just going to be square root of 3. So our total volume is going to be this guy minus this guy minus this guy. So our volume, I can pull out a 1/3 pi from all of those, and I can pull out a square root of 3. And what I'm going to be left with is 36 times 6 minus 27 minus 9 on the inside. So I'm going to get V is equal to 1/3 pi square root of 3 times 36 times 6 is 180 plus 36, so 216 minus 36 is going to give me 1/3 pi times root 3 times 180. 180 divided by 3 is 60. Sorry, I accidentally put the pi in the denominator there, so this is pi is in the numerator. So we're ultimately going to get the volume is equal to pi times square root of 3 times 60. And that is going to be our final volume here. I appreciate you for joining me on that problem. Hopefully it was fun if you went ahead and tried to solve it yourself. If you have any of your own problems that you'd like me to work through, go ahead and submit them and I can take a look at them, and you may see them in a future video. If you enjoyed this content, please like and subscribe. And as you're problem solving, always remember to think thrice.